Hi, I'm Cheryl Leach. Today we're going to look at finding the equation of a line that is tangent to a given curve, but also parallel to a given line. The function that we're going to be looking at is f of x equals -1/4 x squared. So we want to find something that the equation of a line that's tangent to that curve, but is also parallel to the line x plus y equals 0. Now, to get the equation of a line, you need two things. You need a point that's on the line, and you need the slope. Unfortunately, with the given information, I don't know a whole lot about the point that's going to be on this line, but I have a lot of information about the slope, so we're going to start there. There are two facts that I can take with me about the slope of a line that's tangent to this curve, but also parallel to that one. The first fact, so we'll say fact 1, is that the slope of a tangent line is the derivative of that function. So we know that the slope is going to equal the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So let's do this evaluation. As always, I start from the inside out. I'll start with the function evaluation of f of x plus delta x, which in this case is going to be -1/4 times that input, x plus delta x squared. Next, I'll subtract f of x, which means I'm subtracting a -1/4 x squared, and divide the whole thing by delta x. In order to evaluate this limit, I'm going to need to do some algebraic manipulation of this expression, which is going to mean foiling out x plus delta x and also combining some like terms. So let's see what happens. The limit as delta x approaches 0 of -1/4. When I use FOIL on this piece, I'm going to end up with an x squared plus 2x delta x plus delta x squared, and then I have a plus 1/4 x squared all over delta x. Continuing on, I have the limit as delta x approaches 0 of -1/4 x squared minus 1/2 x delta x minus 1/4 delta x squared plus 1/4 x squared all over delta x. The -1/4 x squared and the positive 1/4 x squared add together to be 0. And I also notice that the two terms that are remaining have a delta x in them, so I can factor a delta x out. I have delta x times the quantity minus 1/2 x minus 1/4 delta x all over delta x. I can now cancel my delta x's, and I have the limit as delta x approaches 0 of -1/2 x minus 1/4 delta x. And as delta x approaches 0, this expression approaches minus 1/2 x. Okay? So that's the slope of my tangent line at any point. And that's fact 1. Now for fact 2. We can also find out information about the slope of the line based on our given line x plus y equals 0. We know that our line needs to be parallel to x plus y equals 0. So let's take a look at this. X plus y equals 0. This is the general form of a line. It'll be very easy to read off the slope if I just put it into slope-intercept form, which means all I have to do is subtract x from both sides. Now it's in the form y equals mx plus b, so the slope is a -1. And the slope of any line parallel to this one will also be -1. So if -1/2 x is the slope and -1 is also the slope, that means that those two must be equal to each other. So -1/2 x must equal -1. Well, what does that tell me? It tells me that I can solve for x, and that x is going to be 2 if these two expressions are equal to each other. Well, if x equals 2, I can find out what the y-coordinate is by evaluating f of 2. So what is f of 2? F of 2 is -1/4 times 2 squared, or in other words, a -1, which means that the point 2, -1 is on my graph. All right, now what does that tell me? Well, to get the equation of any line, I need two things. I need a point, which I have. That's going to be the point 2, -1, and I need the slope. Okay. Now I have two versions of the slope, but look, I know that the slope is a -1, so this is going to be the easier one to use. So I'm going to say that the slope is a -1. Now I can simply use my point slope formula. Y minus y1 equals m times the quantity x minus x1, and plug in my given information. So I have y minus a -1 equals slope, which is -1, times x minus the x-coordinate, which is a 2. Y plus 1 equals a -x plus 2, and so y is going to be a -x plus 1. And I now have the equation applying to this curve, which is also parallel to the line x plus y equals 0. I hope that was helpful. Thanks.